Now we're going to compute confidence intervals, and I have 4 that I'm going to compute for you. They all have slightly different styles. Now, it might be that I give you something in closer to a paragraph form. It might be that I tell you that a sample of size 45 has a mean of 12.4. The standard deviation of the population is known to be 1.06. Find the 95% confidence interval for the mean of the population. Now, this is what I would write out. What I want you to write down is n, x bar, sigma, and the confidence interval. If you know what sigma is, then it's a z-interval. If you don't know what sigma is, and you have to use the standard deviation from the sample is s instead of sigma, then it turns out it would be a t interval. These are handled in close to the same way. T interval, z interval. Up above, this was for a z interval. The difference is whether you have a sigma or an s in the formula, and whether you use the numbers at the bottom for the z-score, that would be for z sub alpha over 2, or if you use them up higher based on the degree of freedom, and that would be for t sub alpha over 2. Let's do the t interval first. We'll take our calculator and we'll go stat tests. You're going to spend a fair amount of time doing stat tests in the next sections. I'm going to page down until I see t interval. I hit enter. It asks whether I'm going to be using raw data or summary statistics. Now, these are summary statistics, so I have to go right arrow, enter, summary statistics. It asks first for x bar. X bar is 5.0. No need to type the 0.0. The calculator would ignore it anyhow. The standard deviation is 0.47. N was 12. The confidence level that we're looking for is 90%, which is 0.90. That's the same as 0.9. So I'm going to go down, calculate. It takes a little while. It's actually computing t sub alpha over 2 when it does that. Do you see the report, the x bar, the s, the n? That's why I like the report here as well. It also gives a confidence interval from here to here. For decimal places, I want you to key off of the number of decimal places in x bar. I want you to match that. So here it would be from 4.8 to 5.2. So this would be the 90% confidence interval for the mean. Next, the z-interval. Almost the exact same thing. One important change. Stat, tests, instead of going down to line 8, the t-interval, you go down to line 7, the z-interval. And that's pretty much the only change. This time you'll notice it asks for sigma, and in this case sigma is 1.06. X bar is 12.4. N is 45. And the confidence interval that we're looking for is the 95% confidence interval, 0.95. Now I want you to calculate. So it'll tell you x bar and n. You already told it what sigma was. So it looks like it goes from, well, let's see, 1 decimal place for x bar. So I want 1 decimal place here and here. I'm going to say that that is from 12.1 up to 12.7. So that would be the 95% confidence interval for mu, the population mean. I'm 95% certain, based on this being a representative sample, that mu lies between 12.1 and 12.7. Now, you notice that the first choice we made was between using raw data and summary statistics. Suppose that I give you a bunch of raw data, either like this or like this. Now, for one of them, I'm going to tell you a historically known standard deviation. This often happens in quality control experiments. So let's take the right side. Suppose I tell you that there's a historically known standard deviation of 8.21. Now, by telling you that that is a historically known standard deviation, we're not using the standard deviation from the sample. We're using what is hopefully a better standard deviation. But that means that this is going to be a z interval, while this, because I don't give you a sigma, you have to use the standard deviation from the sample. This is going to be a t interval. Next step, in your calculator, stat edit. I'm going to type in the numbers. So that's going to be 8, enter, 5, enter, 7, enter, 12, enter, 5, enter, 9, enter, 10, and 10, and 11. Now when I hit enter, the next would be the 10th, so I should have 9 numbers there. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. Just a little bit of error checking. Now I've put them into list 1. Now I go stat tests. It's going to be a t interval, so I go down to line 8. And you see how it has a t interval, but this time I used raw data. So I'm going to switch. Now it's highlighted. You do have to hit enter. And do you see how the menu changed? I did use list 1. Frequency should always be left at 1 for this class. Confidence level, well, I asked for the 99% confidence interval, so I'm going to have to switch that to 0.99. And then I calculate. Now, raw data had 0 decimal places, so summary statistics should have 1 decimal place. So I'm going to make this 5.8 to 11.6. Now this is going to be the confidence interval, but you're not done. This information is nice. It does answer the question, what is the 99% confidence interval? But in doing it, you got some additional information, and I would like you to write that down. For example, you got X bar, S, and N. Now, for this section, I want X bar to be 1 extra decimal place compared to the raw data. I want S to be 2 extra decimal places. The reason why I want that is because from the formula, it gets used as part of a calculation. So it's possible that its impact can be made larger than intended by rounding. So I would like you to write x bar equals 8.6. I would like you to write S, remember it's S because it's a t-interval, is 2.51. And n is 9. So this is what I'm looking for. I also think it's helpful for me to understand your thought process and for you to follow along the right way, to write at the top whether you're doing a t-interval or a z-interval. This problem. So now I'm going to go Stat, Edit. I'll switch to List 2. I'll type in the numbers. So it's 108 and 113 and 97 and 112 and 101 and 110. The next line would be the 7th number, so I must have typed in 6 numbers. 1, 2, 3, 4, 5, 6. Now, Stat, Tests. Since I know what sigma is, I'm doing a z-interval, so I'm going to go down to line 7, z-interval. I'm going to keep it on raw data. Sigma 1.06 was from the previous z-interval I did. I changed that to my known sigma of 8.21. The numbers I put into list 2, so I hit the second button and then the 2 to get list 2. The frequency gets left at 1. The confidence level changes to 0.90 or just 0.9. And we calculate. Now again, 1 extra decimal place. So the data had 0 decimal places. I want you to put in 1 decimal place. So it would be 101.3 on out to 112.4. If it's exactly 5, you still round up. Again, it does give me summary data, which I find interesting. I want you to write x bar is 106.8. That this S, I don't need you to write it down. If you do, I don't have any objections. I tend to just look and see if S is close to sigma. Sigma was the value that we used. S is of some interest to me. Lastly, we're going to write n is 6. If you write it like this, I'm fine. If you include that S is 6.43, that's also acceptable. Last thing. As with workbook 7A, on one of these, I'm likely to ask you for a plain English statement of the results. Since we've used this one here and here, why don't we do the plain English results on this z-interval? As before, I'm going to start with one qualification. Based on this being a representative sample. Again, I'm allowing you to use the acronym BOTBARS, based on this being a representative sample. Now that's the first qualification. I am 95% certain, and I do want you to use the percentile instead of the 0.95 that you used in the calculator. But this is the second qualification, that the population mean lies, and the final qualification is you don't say what the population mean is, you just say that it's likely between two numbers. So it lies between 12.1 and 12.7, and you might have to add the types of units. Were these measurements of people's ages? Was it the number of inches tall that a certain bird species was? Is it the number of ounces that the gravel happened to be? These numbers could be lots of different things. In the problem, sometimes I will give you units. If I don't, either say units or leave that blank. But if it is age, you would have put in years. If it was height, you would have put in inches. If it was weight, you would have put in something like ounces. So this is going to be the plain English statement. Based on this being a representative sample, I am 95% certain that the population mean lies between 12.1 and 12.7 units.